Good morning, Year 5s. Thursday, and it is time for our maths. Thank you for tuning in. So let's get cracking, shall we? I'll do now first, and I think, like I've said the last couple of days this week, this should be relatively in the bag for us all. So, how many metres in a kilometre? Well, there's 1,000 metres in a kilometre. That should be a known fact now. How many sides does a heptagon have? Well, hept is 7. Now, you may not have remembered that, but use a bit of logic. You know, quad is 4, tri is 3, quad is 4, pent is 5, hex is 6, and then you know oct is 8. There's always, we always miss 7. So heptagon is 7. Ooh, hept. Heptathlon, I believe, is 7 events. I don't know if it's in the Olympics. What does it mean to rotate something 540 degrees? Now, you need a little bit of knowledge of 9 times table here, and turns. First of all, you should know a full turn is 360. Okay? But with this question, you just need your 9s knowledge. So, every quarter turn is 90 degrees. So, 90, 90, 90, 90 is 360. Well, 9, 18, 27, 36 is there. So how many 9s is 54? Well, it's 9 times 6, isn't it? Okay. So you need 6 quarters. So let's get another 2 90s there. 9, 18, 27, 36, 54, 45, 54. So to rotate 540 degrees is 1.5 turns, so it's 1.5 turns. But I'm pointing out, when you're doing degrees and rotations, you can use your 9s. So, you know, anything in the 9s can be some sort of rotation in a quarter or a half or 3 quarters. All right? Roman numeral is 49. Oh, right, so it's, let's look at the 40, which is, because some people say, oh, this is 1 before 50. No. So it's not IL. No. Let's look at the units. So the 40 is 10 before 50, and then the 9 is 1 before 10. Okay, let's go this one. XCVIII. So 10 before 100 is going to be 90. 5, 6, 7, 8. 98. There we go. 609, well, how to do 600? Well, we've got D, which is 500, C, which is another 100, so that's 600. As we know, there's no 0 in the Roman numerals, so we don't need to worry about any sort of 10s, we just need to put our 9, which is 1 before 10. Our fractions. So we've got a mixed fraction here. We need to make it into an improper fraction. So, how many 4s? 8 times 4, so 8, 16, 24, 32. And then we've got an extra 7, so that's going to be 39. There we go. 17 sixths, how do we make that a mixed fraction? So how many 6s go into 17? 6, 12, 18. Oh, right, okay. So 6, 12, that's 2. And, well, we know it's 5 because one more would have got you to 18, which would have been another whole 6 pieces. And then the last one, we want to try and do both, don't we? So let's do our improper first. We'll put our improper on the end here. So, 11 and 9. Well, that's 20, isn't it? There we go. So, how do we make that into an improper? So, how many 15s are in 20? Well, we've got 1, obviously working in 15s, and an extra 5 to get to 20. 1 and 5 15ths. Lovely jubbly. Right, on to what we're looking at today. So the last couple, the last couple of days we've been looking at volume, and I just wanted to have a quick look at capacity because they can sometimes get muddled up. Capacity is how much of something is in a container. You tend to use millilitres, litres, centilitres, which we'll look at in a minute. Volume is how much space is in the shape or the container altogether, and how much it takes up. Okay, So there is a slight difference with them, but you can work out. Well, you can work them out in separate ways. So we've looked at volume, capacity is this. So at first glance, you might be thinking, "Oh, I've done stuff like this in year 2 and year 3." Well, yes, you have, but no, it doesn't get recapped very often because we get so hung up with all our calculations and this. And actually, working out the increments on a scale can catch some people out. And you may be watching this video going, I behave. I've had some year 6s in revision clubs not be able to do this because they're so hung up in calculations and angles and working out perimeter volume and all that. And sometimes some of the basics get forgotten. So, all you need to do in this first one is, if you add 200 millilitres of water in each jug, what would the new reading be? At first, sounds like a very simple job. You've got to make sure you know the increments of the scale. So this first one here goes up in 250s, but you've also got to work out what these smaller ones go in. Now, it can't go in hundreds, 850, 950, it doesn't work there. So could it go up in 50s? 800, 850, 950, 1000? Yes. So you've got to use some common sense knowing what increments can go in. So if you add 200 millilitres to that one, well, you didn't even need to work that out for that one because it's already on the 750. So add 200 it'll be 950. So 950 millilitres. On this one here, you are going to have to work out what the increment is. Whoops, sorry, get the tripod. So we've got a gap here, 5, 6, 7, 8, 9. Yeah, so you can work it out. So it's hundreds. So 500, 600, 700, 800, 900, 1000. Which means that's on 400. So the new reading is going to be, if you add 200 more, it's going to be 600. Okay? Whoops. Catching everything today. Right. Next ones. How much water is required to fill it up to 800 millilitres? So once again, we've got it here. We'll just check. It's probably going to go in 50s. 253, 450, 250, 300, 354, 455. Yeah, so it's going up in 50s. So how much more do you need to get it to 800? So if it's 354, oh, that's easy. You're on 400, you need 800. You double it, so you can need to put another 400 millilitres in. And then this one over here was going up in, was this the one that went up in 50s? 500, 556, no. Was it going up in hundreds? 5, 6, 7, 8, 9. It was going up in hundreds. So if this is on 5, 6, 700, well, you need another 100 millilitres to get to 800, don't you? Lovely. This shouldn't be catching anyone out, by the way, guys. This is so much of just a quick recap. You know what you're doing here. How much water should you pour out of the jug, out from each jug to drop down the water to 300? The other thing I'm curious of is how many of you just rushed through this and read the increments on each one and didn't read the question. That will be interesting. So we need to get it down to 300 now. So what are we on with this one? So this is the one that was 50s, wasn't it? 500, 556, 657, yeah. So this was the one that was 50. So it's on 600. You need to do 300. Oh, well, that's half, isn't it? So take 300 out. Job done. This one here, I keep forgetting what the increments were. 100, 200, 300. Yeah, these ones were hundreds. So 5. So it's on 1,700. Well, if you take away 300, you'll find the difference with this one. So this one should be 1,400. So if you pour out 1,400 millilitres, you'll get down to 300. Lovely. Now that is not the end of your maths today. You know, I'm hoping that one didn't catch us out. I want to have a look at centilitres. Now, centilitres you can actually see more and more often than you'd think. It's on a lot of bottled things. It's on quite a lot of wine bottles and beer bottles. I'm seeing it a lot on milk cartons as well, actually. So centilitres is quite common, but we don't tend to talk about them. We always say millilitres and litres. So the first ones here, you've got 33 centilitres, 115 centilitres, and 11 centilitres. We just need to put these into millilitres. So you need a couple of skills here. I'm going to go straight to the top of this page. 100 centilitres is 1 litre. Now, you should be able to work that out because you know centi. Cent is 100, isn't it? You know, if you think about America, it's 100 cent in a dollar. Cent is Latin for century is 100. We have a C for 100 in our Roman numerals. So there are 100 centilitres in 1 litre. You should also know that 1 litre is 1,000 millilitres. Okay. So I've written these down here. So the first one is that little jar that says 33 centilitres on it. What I would do here is I would convert it to litres and then put it into millilitres. Okay. So first of all, centilitres into litres. Well, we can do our divide by 100 trick, can't we? Boof, boof. So 0.33 litres, which you should know is 330 millilitres. Now I've written that out, you should be able to see some sort of pattern here. If there's 100 centilitres in a litre and 1,000 millilitres in a litre, well, maybe we could just add an extra 0 here. So maybe we can just times by 10. Because if we're going from 100 centilitres to 1,000 millilitres, there's an extra 0. So if we add that extra 0, so times by 10, might make this task a little shorter. I'm still going to put the litres in, but I'm going to show you the millilitres straight away with this one. So you're on 115 centilitres. If you times it by 10, you get 1,150 millilitres. If you divide by 100, you get 1.15 litres. Okay. This last one here, 11 centilitres, times by 10 to get it to millilitres, you got yourself 110 millilitres. If we convert it to litres, 0.11 litres. Okay, or 110. So, just a little insight into centilitres there. There is another task as well. So we need to convert these into centilitres. Now this is another reason why I've written this out here. So you can see the very simple number pattern that's happening here. So if it's 33 centilitres, it's 330 millilitres, and it's 0.33. Really, there's an order that you can put these in, isn't there? You could really go litres, centilitres, millilitres, or millilitres, centilitres. You could put them in an order. So 600 millilitres into centilitres. I'm going to look at this first one to help me out, because this one was 330. You know, we've got 3 digits, it's in the hundreds here. So if 330 millilitres went to 0.33, surely 600 millilitres is going to be 60 centilitres. This one here, I like this one, 9/10 of a litre. Instantly your brain should be going, right, 9/10 of a litre, well that's 0.9. Okay, 9/10 is 0.9, we know that. So, this one's going to be 90 centilitres. Because we know 100 centilitres is 1 litre. And then 90 millilitres is very similar to... Ooh, it's not quite very similar to that one actually. It's a little bit less than that one. So, well, 100... So, getting all my words muddled up. That's that one. So this one is going to be 0.0. No, wait, no, it's not. There we go. So, I'm not convinced with that one myself now. Get myself all muddled up this morning. That is just a little insight into litres, millilitres and centilitres. I'm going to be completely honest. Your litres and your millilitres should be absolutely sorted by now. Maybe just a little reminder that it's 1,000. The centilitres you may not have looked at before, okay? But the skill of multiplying and dividing by 10,000 comes into play again. So I'm hoping that you've got this sorted. And you know what? My brain has gone completely dead in this last one, so I am just checking. Oh, it was 9. Why did I put 0.9? Deary me. My brain went then. I'm sorry, guys. Right, there we go. So, hopefully that helps a little bit. You do have one last task as well, which is the classic of all classic capacity lessons, where you've got to go and do some estimating. And you know what? You do this a lot in your school life, and I still see kids in year 5 and 6, and even adults, not estimate capacity very well. So I want today, you know, drizzly day again, probably be inside, grab some bottles and jugs, see if you can measure how accurate they are. So look at the bottle, you know, you can either estimate the entire size or like draw a line on it and say, I reckon up to there is going to be a certain amount. Maybe you get 5 or 6 and the first 3 is the full amount, and then you put a line, you draw a line on it, and you go, right, I reckon up to here is going to be this amount. It'd be brilliant if you could start doing some of your estimates like this. So I think it's 330 millilitres, which is 0.33 litres, which is 33 centilitres. That'd be brilliant. That'd be, you know, if you did that in school, you'd be getting your house points for that. Okay. So 5 or 6 estimations, different things around the house, and then pour them out into a measuring jug and see how close you were. Simple as that. Enjoy, and thank you for that, guys.